So we will start with ensemble learning. So what is ensemble learning? Basically, ensemble learning is a type of learning which combine multiple weak learners to form one strong learner. Okay, so let me tell you this with the help of an example. Suppose if you ask a complex question to a thousands of random people and then you just aggregate the answer, in many cases you will find that this aggregated answer is the better than any expert's answer. Okay, so let me tell you this with the help of one use case, that is everyone in India or anywhere outside India, we know what is voting. Okay, we know about what is voting. Okay, so let me tell you that suppose we have a group of suppose you can say 30-40 people. Okay, we have one club of 30-40 people. Now we have to choose the president of the club. We have three candidates. Okay, and now the voting happens. Everyone casts the votes, and one who get the majority of votes wins the election and will be the president of that club. So keeping this scenario in mind, let's apply this in ensemble learning. Okay, ensemble learning basically deals with the wisdom of the crowd. Okay, in this group, every person casts his or her vote in the favor of one candidate. So each vote is a weak learner. You can treat each vote as a weak learner. Similar way, ensemble learning combines these multiple weak learners to form one strong learner. That is, in our case, is the president of that club. Okay, so when compared with this single model, you can take any single model, maybe it is logistic regression, maybe it is decision trees or any other model. So this type of learning builds with improved efficiency and accuracy. Okay. So this is basically the idea behind ensemble learning. So as you can see on your screen, we have the diverse predictors. Okay, these are different models. Maybe one is decision tree, one is logistic regression, one is SVM. Like this, there are different models. Let me show you this with the help of a pen. So this is the first model. This is the second model. Likewise, we have four models. Okay, we have passed a new instance to all these models. Okay, so now this model gives the output as 1. The second model gives the output as 1. The third model gives the output as 2. And then the fourth model also gives the output as 1. So what's the ensemble prediction? As I told you, ensemble combines multiple weak learners to form one strong learner. So you can see that in voting, one wins the election. As you can see, one wins the election. So now one is the ensemble prediction. Okay, so in this way the ensemble learning performs. Now we have different parts of ensemble methods. We have pegging, we have boosting, we have stacking. Okay, ensemble methods are just the methods which apply this ensemble learning. Okay, so bagging, as you all know, in bagging we have random forests. Okay, how they work? They work parallelly. Second, we have boosting, they work sequentially. And another, we have stacking. Okay, stacking, it is basically a different paradigm. The point of stacking is to explore a space of different models for the same problem. Okay, the criteria of this lesson, this session is basically on boosting. Okay, so before moving directly to boosting, let me tell you the difference between the bagging and boosting. As you can see in this slide, uh, in bagging we have a parallel approach for the weak learners, and in boosting we have the sequential approach. Okay, bagging, where weak learners are produced parallelly, performance is increased by training the weak learners parallelly on the bootstrap dataset. As you can see that all the weak learners, they are produced parallelly, and in boosting the weak learners, they are produced sequentially during the training phase. Okay, the performance of the model is improved by assigning higher weights to the previously incorrectly classified samples. Okay, it will be more clear. You will be more clear about boosting as you move ahead. So, boosting, it refers to any ensemble method that combines multiple weak learners to form one strong learner.